on problem 8.2, number 17.
All right, yeah.
All right, so
Is that
talking
the
about
one with the children
yeah, how many ways
books?
to distribute the 10 books to the 10 children and then recollect them and distribute them again so that each child gets a new one. So I understand that obviously the second part is going to be a derangement because it's like, the condition is that no book can go to the same child, twice in a row, basically. So it's like you have the first one is like a permutation, and then the second one is like a derangement of that person, of that
Yeah, yeah.
permutation. But I just want to make sure my thinking is correct on the first part, because what I'm basically doing is I say first distribute the 10 books, like the initial one, on
Mm-hmm.
each child, and there are 10 factorial ways to do that.
Yeah.
And then, but for each one of those 10 factorial ways of doing that, you then, whatever you get that first time, you then derange that, which has that many ways of doing that.
Right.
So,
So basically without loss of generality, I mean it doesn't really matter necessarily where the books went the first time, right? I mean, if you just know that they went somewhere. And then
uh,
whatever they are, like the first child you might as well label that book with number 1 or something, right? So then it's obviously just going to be a derangement of whatever that is. So without loss of generality, the first distribution might as well, like the first book went to the first child, the second book went to the second child, whatever, right? So
okay. See
yeah.
okay, so that I'm pretty sure that answers my question, because the thing that I was thinking was, because of how the exact wording of the question is, how many ways are there to distribute 10 books to 10 children, one to a child, and then collect the books and redistribute them with each child getting a new one. So because of that word "and" there between the part where you like initially distribute them and then
Uh-huh.
redistribute them as a derangement, I thought that um there could potentially be two cases. Like, let's say in one case, child one gets book one, child two gets book two, etc. But then the derangement ends up being, let's just say, the exact reverse of that. Child one gets book 10, 10, 9, 8, 7 to 1.
Yeah.
But then you would have another case that doing it the way I did it would be counted separately. And that is where, let's just say, child one got book two and child two got book one, but then everything else was the same initially. But then the derangement could be the same as the derangement of the first case. And that's where I'm confused, is like, would that be counted as a separate occurrence? Since
Well,
since the first phase was different, but the second phase ended up being the same.
did the question say what's the probability that happens, or does it just say the number of ways?
They just said how many ways.
Right. So yeah, then it's just, I mean the answer's got to just be
The derangement part.
what's that?
It's basically the derangement part is the only part we care about.
Well, well, you first, in the first case you just freely distribute the books, right?
Hmm.
10 factorial.
Right.
That's stage number 1.
Right. Oh, okay.
Stage number 2, you're going to just derange
Right.
whatever happened in stage number 1, right?
Uh-huh.
So the answer's got to be like 10 factorial.
Times whatever the derangement formula for 10
Yeah,
is, basically.
times d sub 10. Yeah.
Okay. Okay, that's how I did it. I probably just didn't explain it very well, but that's basically how I did it, and I just wanted to make sure that, taking that initial one, like all those 10 factorial different branches before the derangement happens, is
Yeah.
the way to go.
Yeah, right, because the derangements will look different, but it's still, the number of ways to do it is still a derangement. So like for instance, I mean, just to think simply about it, suppose it was only 3 books,
Hmm.
and maybe the first just distribution of the books was 3-1-2 or something. Yeah.
Hmm.
Then the next distribution, you just need to make sure that 3 doesn't go in position 1. Yeah.
Hmm.
1 doesn't go in position 2, and that 2 doesn't go in position 3. Yeah.
Mhm.
But that's really no different than the derangement number, right? Because you're just
Right. Yeah.
prohibiting a specific element from being in a specific position. Yeah.
Mhm.
So it
Yeah.
still would just be the number of derangements of size 3. They would just look different.
Mhm.
For instance, like if the first distribution was 3, 1, 2, then 1 or 2 would be permitted in the first position, correct?
Yeah.
1 or 2 would be permitted, and you would just be avoiding 3. But look, you could just, you could just relabel everything. You could call 3, 3, 1.
Mhm.
You could call 1, 2, and you could call 2, 3, for instance, right? And then you'll just see the correspondence between what you're doing and the true derangements where you just don't want 1 in position 1, etc.
Hmm.
I'll get in here and, I mean, I think you see clearly what's going on, but I just want to make sure.
Mhm.
Um, and of course, as you know, I mean, people watch these and learn stuff, so
Mhm.
I think.
I mean, I definitely watch them and learn stuff.
Okay, yeah. Okay. Here we go. Okay. So like, I mean, just to make it totally clear, Paul.
Mhm.
So like if n was equal to 3, right?
Mhm.
Then maybe in the first stage, so maybe in the first stage, you kind of do, you distribute the books this way, right?
Mhm.
Then in the second stage, you want to build. So that means, right? So this means that child 1, so
Mhm.
this was child 1. Child 1 got this one. Child 2 got this one, and child 3 got this one, right? That's what this means.
Right.
So in the second stage, you'd better not, right? In this position, you don't want to see, what don't you
3.
see? What's that?
Yeah. So in that position, you don't want to see 3.
Right. And in this position, you don't want to see
1,
1. And in this position, you don't want to see 2.
2.
But you can completely translate this, right? You can kind of, you could replace 3 with 1 prime, right? You could replace 1 with
2.
2 prime, and you can replace 2 with 3 prime. And then basically, what would you be asking to have happen here? Right? This one, you would say that the first position couldn't be what?
Uh. Well, in that
What-
case, it couldn't be 1 prime,
Right. And then this one, it can't be,
2 prime, and then the
yeah,
last one can't be 3 prime.
right. 2 prime. And this one can't be 3 prime. And then you're like, oh, I see why it's a derangement. You're just saying the first element can't be in the first position, the second element can't be in the second position, etc.
Oh yeah, I see what you're saying. So you're basically saying just you're using the primes as a way of talking about which one came first or came
Yeah,
second.
yeah, yeah,
And
yeah.
okay, and that just helps with the difference. Okay, yeah, I get that part. Yeah,
So
I guess
yeah,
the real essence of the thing that was confusing me about it was I have that represented here. I don't know if you can see it, but here's a case where n equals 4. So initially you have, let's just say the initial one was 1, 2, 3, 4, and obviously a derangement of that would be 4, 3, 2, 1.
yeah.
But is that counted separately under this way of doing it? Is that counted
Oh,
separately from this? Because you end up in the last phase, you end up with the same derangement, but you initially had something different. So
I see. So what
my
you're saying
question is, would these be separate, basically? Which I think it would, because based on the way the problem's worded and the fact that we have the word "and" between the first thing happening and the second thing happening, I think it's saying
I,
like, oh,
yeah,
happens a number of ways, you know.
yeah, I feel like that would be different because, like, for the same reason, like if we were playing bridge, Paul,
Mm-hmm.
it would be different for the same reason that if I took the exact same hands and just rotated them around the table, we would
Right.
consider that to be different.
Right. Yeah.
Different person has it, even though the exact same hands are playing. We would consider that to be different.
Mm-hmm.
In this case, getting, you know, Pride and Prejudice first and War and Peace second, you would somehow consider that to be different from because of
Getting green eggs and ham first, and then War and Peace second.
yeah. So I mean, those are pretty advanced books for kids, but you know what I mean, like it's that would be different. Even though you had the same two books, you got them in different ways. Does that make sense?
Yes.
The whole situation is different, and the way they're talking about it in this ordered way,
Mm-hmm.
they'll consider those to be different.
Okay.
So they're just, I mean, there are several problems where they're just wanting you to see derangements kind of arise naturally.
Mm-hmm.
I think several of the problems I gave you are derangement problems, basically.
Mm-hmm.
Yeah.
Cool. And then just a very, very brief question on number 18. We are supposed to have like two very similar, but two technically different formulas for whether n is odd or n is even, right? Because if you think about it, if n is even, then you have a total of n over 2 odd numbers that you're dealing with. Whereas if n is odd, you have n plus 1 over 2 odd numbers that you're dealing with.
Yeah, it will be different, but the first part of the formula should look exactly the same. Where it should really look different is at the tail end of it. You kind of have to fiddle with the end of it. I think I talked to somebody asked me about this. Who it might have been like Ilona or maybe
It was either Katie or Ellie or Ilona in
yeah.
the video from Tuesday class period, I think.
Yeah, so
And that was very helpful, but I just want to make sure, because I think because more of my formula ended up looking different, so I'm not sure if I did it right. But basically, the main difference between my formula is the fact that like when n is odd, say you have like like you have the size of the universe minus s1 plus s2. For each of my s's, you essentially have n plus 1 over 2 choose whatever you're doing, because that's how many total odd numbers you have, and therefore that's how many like of those sets you have of like a sub 1, a sub 3, a sub 5, and stuff
right.
like that. So that has to account for every odd number in the sequence.
Yeah.
So if n is odd, you're going to have a bunch of like n plus 1 over 2 choose something. Whereas if n is even, you have a bunch of n over 2 choose 1 or choose 3 or something. Or rather choose 2, because for like double intersections and stuff like that. So
Let me hang on. So
I could write out part of it.
it is
Like I'm
odd.
not
Oh, okay.
like I'm
So
not
but
going to write out like
isn't is it really different? Because isn't n over 2, if I take the ceiling of n over 2, what doesn't that equal?
oh. You're saying like n over 2 would just be literally n over 2 if n is even, but so of course that's covered by the fact that you use the ceiling.
Yeah,
But if n is odd, then that would
it,
still, if you
it
have the
would be
ceiling,
n
then
over 2
technically,
plus a half
yeah.
if n is odd. And by the way, n over 2 plus a half is what you said in plus 1 over 2.
That that makes sense. That would um create a lot more uniformity than what I've been using.
Right. So I mean you could do it the way that you did it and have two cases, but I think this is a way of turning the two cases into one case.
Nice. I like
Okay.
that.
Yeah.
Okay.
Yeah.
Very cool.
Is it n over 2 plus a half if n is odd? Is that what that is? Probably.
Uh,
So if like n was 5,
mhm.
be 3, and 5 over 2 is 2.5, and if you take
Yeah.
3, yeah.
Yeah, that works. Yep.
Mhm.
Yeah, I kept going. I kept kind of thinking that in my head. I was like, oh well, if it's five, then it's just like
Yeah, right.
5 and 7 were like my go-to cases for that.
Yeah, that's right. That's what I always do is I just play around with like little numbers
Mhm.
until I figure out what's going on.
Yeah, play that like numbers that are little enough to be easy, but also big enough to have like a small handful of things actually happening before you get to that number.
That's right. That's right. Yeah. Yeah.
Yeah. Okay. All right. Yeah, I think I can make that work out better than I had.
There you go. Yeah.
Yep.
Cool. So this first one was number 17, right?
That is correct. Yes.
And this second one was number 18. I've just been kind of updating that document my own self sometimes.
Yeah.
It's
Yeah.
easier for me to do that now for whatever reason.
Huh. Cool. All
All
right. Well, that's all I had for now.
right, everything else going okay?
Yeah. It's just just being at home, doing everything online. It's when you're not regularly forced to see all the classmates and see all the profs, it's not quite as easy to stay motivated to do all the work. But overall things are going well.
Yeah. All right. Well, cool.
All
Glad
right.
to hear it.
All right. Well, I'll see you later, Dr. Hammett.
All right. See ya. See ya, Paul.